Today we are going to discuss very briefly introduction to cloud computing. I hope you are hearing me.
Yes, we are.
Okay. It's just going to be a brief discussion on cloud computing. And probably by the time we finish, we'll look at some very hot research issues that are around cloud computing. Basically, now almost everything is going to the cloud. Even before COVID, but with COVID now, almost everything seems to be all around cloud computing. So I will just do a very quick introduction to cloud computing. So we are going to be looking at what cloud computing is, the concepts around cloud computing. We will talk briefly about the enabling technologies. We look at the there seems to be some misconception between cloud and grid computing. I'll just look at probably a few differences between cloud and grid computing. Then we also discuss very briefly on virtualization, which is one of the enabling technologies for cloud computing. Then probably we discuss challenges from the provider perspective, from the consumer perspectives, and also advantages and disadvantages of cloud computing. So by the time we finish today, hopefully, we should be able to understand the basic concepts behind cloud computing. We should be able to describe the different kinds of services and deployment models. We should be able to understand what the infrastructure behind cloud computing looks like. And we look at some of the challenges behind cloud computing. So if you look at this slide, you will see the background looks like a cloud, and every other thing that you see on it are things that you find in the cloud or on the cloud. So basically, cloud computing is let me describe this like someone who wants to go to you want to go somewhere and you don't want to use your vehicle for obvious reasons, and you decide to join a bus, let's say a BRT bus, like those in Lagos. Now, as far as you are concerned, all you need to do is buy your ticket, enter the bus. When you get into the bus, definitely you meet several people on the bus. But as far as you are concerned, where everybody in the bus, where they are going, is not your business. Your major business is where you are going. You want to arrive there safely. That has to do with security. And you want to get there on time. So you want to get there in one piece, and you want to get there on time. At the same time, very likely one of the major reasons why you decide to go on the bus, even though you have your own car, is because of cost. So you want to get to where you are going safely. You want to get there in good time. You want to save costs. So cloud computing is just, it looks exactly like that. Basically, it carries data, it carries information for different people. Everybody minds his own business. So it allows you to use what you need to use or what you want to use to be able to achieve what you want to achieve or get to where you want to get to at a very, at a minimal cost. Something that is not too expensive and you can bear. Not only at a minimal cost, but majorly you transfer your risk to somebody else. That's basically what cloud computing looks like. So there are several definitions around cloud computing, but it's basically something that delivers computing power. You know, it gives you your CPU, it gives you your RAM, you have your network speed, your storage is not a problem for you. You are not looking for where to store. You are not buying operating system. You know, it delivers all those things to you over a network, usually on the internet, not always on the internet. That's why I said over a network, but most of the time over the internet. So it gives you all those, everything that you need to be able to do your computing without physically having all those resources at your location. So you find out that cloud computing tries to provide remote services to you. It gives you services, gives you data, everything you want, but basically they are hosted somewhere else. Most often than not, you don't even know where the services that you are using, you don't know where they are hosted. So they are remotely hosted. Those services are available anytime, anywhere you want to use them. It doesn't have to be when you are in your office. As long as the services you are using are in the cloud, you can use them at any time, you can use them anywhere. So it looks like, you know, a commodity, normal commodity thing. You want to buy fuel, gas, you pay for electricity. What it just allows you to do is it allows you to use what you can pay for, whatever you want, as long as you can pay for it. It gives you the flexibility to be able to use it. So this is what it looks like. You can see I want to get a better, okay. You can see that you have different devices around the cloud, but all the things that those devices will be accessing or be using to do their computing, everything is basically right in the cloud. Probably your application, the platform you want to use, the infrastructure you want to use. Basically, all of them are stored somewhere in the cloud. So your cloud computing services offers you some of this. It gives you on-demand service. That means that users are able to provision their cloud computing resources without basically requiring anybody to intervene. You don't need human intervention. You want to provision a server, a web server, you don't need human intervention. As long as you pay for it, you pay online, it gives you access to the server. You can do all your provisioning without even speaking to anybody, and those services become available for you to be able to use. It is also broad network access. So cloud computing resources, you find them accessible at the network. It supports heterogeneous clients, you know, all forms of platforms that you can use. It doesn't basically detect the kind of devices that you use to access it. It doesn't detect the kind of workstations, the kind of computer. It allows you can use various kind of devices to access your services. It also talks about resource pooling. So it serves multiple customers at the same time from the same physical location. Different people will be using different things from the same physical location without any issue. you are using different things, the cloud services allows such provisions. And when it comes to elasticity, it is very simple, it is very fast. It gives you access, it releases access to you as you demand for it. If you ask for 1 meg today, if you pay for 1 meg, you have 1 meg. If you need to go to 10 gigs tomorrow, it is not a big deal. Maybe you pay for it. Your capacity is so elastic that it allows you to be provisioned whatever you desire at any point in time. And like I said earlier, your services can easily be measured. So you also can, it gives you access to be able to monitor the usage of the resources that you are paying for. It gives you access to reports, bills. You know, transparency is very easy. It's based on utilization, and you can monitor whatever you are using at any point in time. So there are 2 basic models. The concepts that on which cloud computing is basically based on. There are 2 basic models. You have the development model, and you have the service model. So I'll go through each of the models one by one. The deployment model just define the type of access to the cloud that you have. So it talks about how the cloud is located, who the cloud is serving, what you have on the cloud. So you have, most of the time, they are broken into 4 different kinds of deployment models. You have the one that is called the private cloud. In the private cloud, the applications and services that are offered in the private cloud are intended for specific organizations or specific entity, such as, you know, government. If you look at somewhere like ABU campus has a cloud. You know, we call it a cloud. I call it a cloud because there is a data center there. So many people are said quite a number of things that they don't even know where it comes from. But I will at some point look at the ABU cloud considerably. I will look at it as probably a community cloud because it serves a community. But the Department of Computer Engineering started doing some kind of started putting some things in place that may just look like a private cloud. What we started putting in place was not even for all the students in the Department of Computer Engineering. We started putting something in place for the postgraduate students of computer engineering, and basically just for the postgraduate students of computer engineering. So such, you can say, is a private cloud. Then you look at the ABU community has a cloud, something that is provisioned basically for the community. Anybody outside the community cannot have access to such a cloud. Then you have the public cloud, something that, you know, the general public will have access to it. It could be business to business community, it could be business to consumer kind of cloud. So in such public cloud, everybody, there is a level of interaction that this computing resource allows everybody to have access to. Then you have the hybrid cloud. The hybrid cloud is hybridizes the public cloud and the private cloud. So these are the development models, the development models on which cloud computing is done. Then the other model is called the service model. And the service models, are also categorized into three basic service models. You have what we call the software as a service. Some also call it application as a service. You have the platform as a service, and you have infrastructure as a service. So the software as a service is more like a software, distribution model. It has applications that are hosted by a vendor or by a service provider.
Yes, sir.
It has applications that are hosted by a vendor, and they are made available to consumers. So in such, you really don't have to start looking for software. I'll give you a very quick example. If you are used to Google, you will discover that Google has something, software as a service. You don't need, if you are using Google Suite, you don't need to even install Microsoft Office. You don't need to install Excel. You don't need to install any of those things. You can do all your word processing, all your spreadsheets, technology stuff. You can do everything on Google, and you don't need to begin to buy licenses. You don't need to use pirated software. You can just go full-blown on Google Suite, and almost all software, application software that you need are available. The same thing with operating system. You have one of the leading software service providers in the world is the Amazon Web Service. You can set up a server with an operating system within very few minutes, and it will be up and running to give you all the services that you want. Then for the platform as a service, the platform as a service is such a cloud that provides platform for you. It gives you an environment that allows developers to build applications, to build services. You want to build a web service. You want to build a mail service. You can build it the way you want. Platform as a service gives you the platform for you to be able to do that without necessarily investing on either the platform itself or even the operating system or whatsoever you need. So platform as a service gives you the opportunity to be able to do that. Then there are several firms also that provides platform as a service. Amazon Web Service also. There is a Rackspace, there is a Zaria. There are so many of them that you can easily just get a platform. You can pay for a platform, and whatever you want, you can deploy within a very short period of time. Then the last service model is called the infrastructure as a service. Now, the infrastructure as a service looks more like a complete package of computing services. Sorry. So what people do basically is that they try to cut costs on IT infrastructure. So it gives you all the infrastructure that you need for you to be able to do whatsoever computing activities that you want to do. So you spend less money. All you just need to do is just pay for a space, pay for the kind of infrastructure that you want, and that infrastructure is given onto you. Things like hard drives, things you can pay for, when you talk of storage. So you don't need to begin to think of building your own storage. You just pay for storage, and when you pay for storage, it makes storage, whatever you pay for, it makes it available for you. Network connections, and several other things that you can, several other infrastructures that you may need to be able to do your computing. Okay, so when you look at cloud services, you can easily recognize when you are using a cloud service. One, they are not installed on your system. You are using Google Docs. Immediately you go away from you go offline. You can still have your Google Docs there, but it's going to tell you that you are working offline. It's not going to synchronize until you get back online. So when you are using Microsoft Office, that is not installed on your system, is kept somewhere. I remember those early days. Prof is online. Those early days when GSM first came into Zaria, if you lose your phone, you lose everything. You lose your SIM, you lose everything that is on your phone. But today is not the same. You can change your phone right away, and it seems as if it's the old phone you are using, because most people now store their data in the cloud. So if you use Google and you have Android phone, immediately you buy another phone and you log into your phone. Everything without trying to move anything by yourself, everything that you have stored on the old phone gets on the new phone. So with this, you have a clear understanding that you are using cloud services, because those things that you are using, they are not resident on your system. And the beauty of it is that you can access whatsoever you have done in the cloud. You can access them from anywhere. At some point, I'm sure very soon we'll get to that point that you may not even need to own a personal computer. Wherever you get to, you get a computer, you get a device, you just log into your cloud service, and you can have access to anything and everything that you have worked on or that you are working on. Okay, so if we look at a bit of some of the challenges that comes with cloud computing, maybe from the provider's perspective, the providers will have quite a number of challenges, because when people pay for something, customer is always right. So for you to even be able to provide some of these, for people to come on and subscribe to some of these things, providers have to ensure that their service warranty and their service cost is something that is competitive. They have to ensure that whatever they are putting on ground is always ready to meet any kind of demand. Like I said earlier, today you may subscribe for 1 gig of storage, and because of anything happens tomorrow, within 2-3 days you may want to upgrade to 1 terabyte. So the provider need to ensure, they have to ensure that they are able to meet any kind of demand that comes at any point in time. Now that's a problem for them, because it means they have to invest on something that they don't even know whether people will buy or not. So they have to put a lot of capital investments, hopefully that at some point people will subscribe to them. because they sign service level agreements with whosoever is subscribed to them. These agreements, you know, there are always very, very heavy penalty if there is any breach in this service level agreement. And those penalty, most of the time, they end up in, you know, financial issues that affects businesses. So they have to be on their toes to ensure that SLAs are always fulfilled. And you know, several other challenges that an average provider is expected to have if they are deploying software as a service. You can imagine how much money they will pay for some of those software licenses. So they incur a lot of costs in trying to ensure. Now, at the customer end, some of the challenges that customers normally have is one, customers always have this issue of security regulations. Most often than not, there are still quite a number of professors on our campuses that are not using ATM cards because they don't just trust these things. And you know, you won't blame them. During their own days, people still go and keep their wares when they are going to. They leave their wares on the road by the shop when they are going to sleep, and nobody is going to touch them. But today, even in your presence, when you are there, people will come and steal your stuff. So security is a problem when it comes to the customer end. Customers will always want to have and to retain the integrity of their data, which is difficult for anyone to be able to be assured of that. In these days of data mining and all stuff, it's difficult for anyone to be able to assure you of your security and your privacy. Also, there are some institutions that may have issues when it comes to regulation that may prevent them from using cloud services. Some organizations will just not be allowed to do cloud services. Then one major problem also has to do with network, because for you to access anything in the cloud, you must have network. And if you don't have good network, you have a problem. So network is always a problem because everything is basically dependent on network. Then support. If you have issues, support is not as easy as knowing the person that is providing service for you, and you can easily just pick a phone and say, look, I have this problem and I need it to be solved. So support may be a problem at some point. Then in cases where you want to use proprietary, whether proprietary in form of infrastructure or in form of software, the service provider that you are using may not be ready to support. If you are a Windows person, and for example, the service provider may not be ready to support Windows. They may be doing free and open source operating systems and application software. So that also may be a problem. Then you also look at the issue of changing providers. At times, it is not very easy to just decide to change providers. Considering the fact that you sign a service agreement with your provider. You cannot just wake up overnight and just decide to just change provider. Anyway, you can do, but it has implications, whether legal or financial implications in trying to change providers just overnight. So most often than not, we are glued to the providers until the end of the service agreement elapses before they decide to change. Okay. These are just few advantages and disadvantages of cloud computing. Some of them I've mentioned in trying to look at the challenges of both at the provider end and at the customer end. For cloud computing, you know, it's very likely that you have improved performance. You are not waiting for your system to begin to boot. You know, some of those things run 24/7, so efficiency, performance is well improved. But like I said earlier, without internet access or without a very good network, cloud computing is basically a no-no. It's just impossible. If we don't have a network, it's basically almost impossible. When we talk of cost, cloud computing brings about a very high reduction in software costs, in hardware costs, infrastructure costs. Is a lot of savings when you do cloud computing. However, like we have said, most of the problems that we have, especially in this our own part of the world, are to do with connections, internet connections, availability, and stuff. When it also comes to investing in things like, you know, computers, it's easier for you to have very high performing computer system that you are paying for when you are using cloud computing, rather than going to buy some of these things and install them by yourself, including software. It's much easier, it's much cheaper for you to do cloud computing. In this part of the world, I have one or two reservations when it comes to cloud computing. Maybe I will leave some of my reservations until the end of the discussion, because at some point I've had some discussions with Google when Google was trying to offer out some things, and I began to question them about what would become of our upcoming engineers and systems analysts if everything is right there in the cloud. Okay, so these are some of the technologies that enables cloud computing. You talk about grid computing, utility computing, virtualization, service-oriented architecture. These are some of the technologies that makes cloud computing to be available to users. So when you talk of something like virtualization, you know that you are paid for a 1 terabyte server that is kept in a rack somewhere, one thing that you are not sure, anytime you check, you are trying to monitor, you are sure that the speed of the server you have paid for is what you have, the storage size is what you have, the RAM is what you have. But one thing that you are not sure is how many other servers are on the same server, virtualized together. You know, you can have one server that is giving 10, 20, 30 services, and everybody just have his own slice of the cake. Just, you know, it's just like a slash, the way it's virtualized. So because of that, you discover that it enables a lot of resources to be put together into a very small space. You don't need to begin to think of how to power your data center. You don't need to be thinking of inverters and stuff. All you just know is that anytime you want, whatsoever you want to do, your server is available. Something that you are not sure of is how many other servers are on the same machine that your server is. Okay, cloud computing and grid computing have a bit of similarities. People mix them together once in a while, but you know, the main idea about cloud computing is to provide the service at a lower rate, more availability to people, less headache. It tries to provide services. It provides flexibility, it provides scalability, you know, so that you can easily do your cloud computing with some very high level of availability and high level of availability and probably promise of some very high level of security also. However, you know, when it comes to grid basically focuses on networks to solve the complex problems. You pull a lot of computer resources together. Basically, all the computers that you pull together in a grid, what you are trying to achieve is that all of them, you are trying to pull all their resources together to solve a particular kind of problem that is complex. So it's not that grid computing is making services available, you know, to different people like cloud computing is going to do. Grid computing is trying to pull resources together to solve a particular complex problem, you know. While cloud computing depends generally on the internet, most often than not, depending on the kind of deployment model, while cloud computing is looking at, you know, the internet, grid computing doesn't look at the internet. Basically, grid computing works, you know, on a network that is built together on, shall they call it grid, a set of computer that is put together because they are solving a kind of problem that seems similar to them. So grid computing is not totally dependent on internet. It's totally dependent probably more on network rather than internet. So the network could just be a local area network that pulls all the resources on all those high performance computers together for them to be able to solve a particular problem. Okay, so you also see that cloud operates a centralized management system. So if you are using cloud and you are subscribed to software as a service, whosoever you are subscribed to, whether it is Amazon, whether it is Rackspace, either of them has a centralized management system for consumers to be able to use. If Grid doesn't do centralized, most of the time Grid operates a decentralized management system because they are computer systems that are just put together on a grid. Cloud computing, cloud servers are owned by infrastructure providers. In grid computing, grids are owned and managed by organizations. So very soon, by God's grace, we are going to have something like a grid computing computer engineering department where we can solve, very complex issues. We've had some of those issues, some of those researches that needed to be done that we couldn't pull some of those resources together. So grid computing, is basically owned and managed by an organization because they are trying to solve a particular problem. Cloud computing uses services like infrastructure as a service, platform as a service, software as a service, but grid computing uses systems, they use distributed computing systems, distributed information, and so forth and so on. Okay. Virtualization, I've tried to talk a bit about virtualization. I'm sure I am almost at the end of this talk. When you talk of virtualization, basically, you are just talking of, having a device that you have decided to slice into different bits, and each of the slices have different identification. They have they may run different operating system, they may run different services. So on the same server, you can have www.abu.edu.ng, www.narict.ng.gov. You can have different services on the same machine, but each of them, they have different identity, either in name or in IP address. Whosoever is using it doesn't know, but that is basically the way virtualization works. So I just put a couple of commercial clouds that you can use. Maybe you are already using some of them. Google, several of them are all over the place. I'm sure quite a number of us are already using some of those cloud services. Well, I think I'm done. Thank you very much. Questions and contributions?
Thank you very much, Dr. Ali. So any questions or contributions?